Welcome back. We're going to begin our discussion on a brand new topic, and that would be titrations. Now, previously, we've learned about the various acid-base theories, right? While each theory might have its own view on how it sees an acid or a base, there lies a common factor, that is, there is an acid and a base. And one way you can combine them and actually understand some chemistry is through titrations. So in a nutshell, there are four basic kinds of titrations. And that's typically a strong acid versus strong base, weak acid, strong base, weak base, strong acid, and a weak acid versus weak base. Irrespective of what your titration is, that's sort of your basic setup for how a titration is carried out. Now, you would typically have two types of liquids. One goes in the burette and one goes in the flask. Now, we cannot keep calling things liquids. At some point we have to get technical, right? And that's one of the takeaway from this video is I want you to be technically very proficient as you leave my class. So typically the liquid that goes in a burette is called a titrate, and what goes in the flask is called a titrate. As much as chemistry is a subject that involves a lot of logic and a lot of mathematics, it's also about patterns, okay? The reason being, if the pattern is kept constant, it's easy to apply the logic, right? Let's say we have a reaction. Typically in a titration, the titrate is written first and then the titrate. I don't know if anybody would write it the other way around because that leads to confusions, okay? Because if you write a reaction this way, then you're implying you're adding titrant into a titrate, okay? That's really what it means, okay? You always add a titrant into a titrate. So the chemical reaction that involves a titration can only be written one way, okay? Writing it any other way can only lead to chaos and confusion. So with that in mind, what do you think is a titrate and titrant in this chemical reaction that involves a titration? Well, we know our titrate is written first, so your HCl is your titrate and your sodium hydroxide is your titrate. What that means is you're adding a base into an acid, okay? If you write it the other way around, then it's the opposite. But the fact of the matter is, you can only write it one way, and whatever way it's written, that's the way it has to be interpreted, okay? All right, moving on. There's two important words that I want you to remember if you want to know the idea of titration, and that's equivalence point and endpoint. What is the equivalence point? See, whether you're adding a base into an acid or an acid into a base, at one point, your base and acid would become equal in quantity in terms of moles. That point is called equivalence point. Now, if you remember the titration we have done, where the pink color comes and goes, at one point, you would actually see the pink color start to sort of remain and then disappear right away. That sort of is the point we call equivalence point. Now, endpoint is a point that usually comes after an equivalence point, where endpoint is where the reaction actually sort of comes to an end. That's implied by the word end in endpoint. And endpoint is where you actually observe a permanent color change. That is, you go from a colorless to a pink or colorless to a blue or whatever be the indicator you've added that controls the color. But endpoint is where you actually see a permanent color change. With that in mind, I want to quickly wrap this video with these three qualitative graphs. Now, these graphs will not be drawn to scale because I'm using my virtual tablet. Now, if you notice in all of them, the y-axis is always pH, the x-axis is always volume of titrant. What you're adding into the flask from the burette determines the direction in which the graph will start and end. Now, if you notice here, this reaction is balanced. Another thing I want to point out, unless otherwise mentioned, always assume all reactions are unbalanced, and you want to make sure you balance, which I did in this case, and it's a 1-to-1. So I'm adding a base to an acid, right? So that means I'm going to start. See, remember one thing, we've done calculations. Typically, pH goes up, right? That means the medium is becoming more basic, right? That means pH, people think pH increasing is more acidic. No, pH increases is more basic. pH decreasing is more acidic. Okay, so we're adding a base into an acid, so we're turning an acid into a base, so we naturally expect the pH to go up, and you're right. So you would expect, right? You see, went up. Now in the next video I would actually explain this graph more, but what I'm trying to say here is the midpoint of this flat region is your equivalence point. Midpoint of this flat region is equivalence point. Okay. Now another thing I want to point out here is, you see we've added more base, so we went from low pH to a higher pH. Right? Now the acid itself here contains only one hydrogen, right? So that's why you have one equivalence point. Now, if you move to this graph here, again, we are having an acid and a base, right? We're adding a base into an acid, so we would naturally expect the pH to go up. But you might be surprised by the way this graph would look like. You see, there's two flat portions, and midpoint of each of this is one equivalence point, right? Why does this graph has two equivalence points? This is one equivalence point, and there's another equivalence point, right? The mid portion of this flat region is the equivalence point. There's two because our acid contains two hydrogens, right? But the fact is the pH still went up. Now we're adding an acid into a base, so we would naturally expect the pH to go down. So, but with base, we don't talk about two equivalence point, at least for this case. Okay, don't worry about it. There's just one nitrogen here, so we would not expect it to have two equivalence point, one nitrogen, so only one equivalence point. So we will start somewhere here, and then we will go down, right? Only one equivalence point. I'm just randomly picking a region that's as flat as possible and marking a center point, right? So that's the equivalence. But what I really want you to take away from this is about the direction in which the graph starts and how many equivalence points do you typically have, right? Typically for acids, we talk about two equivalence points, but there's also bases that involve two equivalence points, which we might learn later. Right? But I want you to take away the idea of equivalence point from this graph, and whether you have one or two, depending on how many hydrogens you have in the acid. Right? I'll see you back with another important video on the topic of titration, which would involve understanding of this video of titrant and titrate. Right? So stay tuned.